All right, hello everyone. Hello ng-conf. Welcome to Stronger Type Checking in Templates with Ivy. For those of you who don't know me, although you should because Aaron just introduced me, my name is Alex Rickabaugh. I'm one of the engineers on the Angular framework team. I've been on the Angular project for over 5 years now. I joined before kind of the 2.0 alpha releases. And for the past couple years, I've been working on the Angular compiler and helping to get it ready for Angular Ivy. And today, I'm excited to tell you about my favorite new feature of the compiler that we've been working on. And it's my favorite feature because we've been getting issues for literally years from users asking for stronger and stricter type checking in templates. And we've always kind of had to explain that architecturally, this just really was too hard to do with the way the previous compiler worked. So it was a real joy as part of building the new compiler to develop a new type checking mode that we call strictTemplates. So you probably already know that the Angular compiler performs type checking of your application templates. And maybe you're already using the fullTemplateTypeCheck flag, which enables the strictest possible checking that we had in Angular's version 8 and below. So strictTemplates turns on an even stricter mode of checking with Ivy. And you can think of it as being similar to TypeScript's own strict flag. If you're not using this flag, I highly suggest that you do. If you turn on strict true in TypeScript, TypeScript will give you the strictest possible type checking that it can do. And it definitely will help you catch more bugs at build time instead of runtime. So strictTemplates is basically our strict true for templates. When you turn it on, the Angular compiler will infer much more accurate type information inside your templates, and that leads to more accurate error messages and more bugs caught at build time. So yesterday, you probably saw Brian Love's talk on why type checking strictness is so important. It's really effective to be able to catch errors early in the development process when it's easy to fix them, as opposed to catching them in QA or even worse, having UI glitches or runtime crashes in production. But another thing that I've noticed in the applications that I write myself is that if I'm using the type checker to catch kind of the basic, more obvious types of errors, I tend to focus my test suite on catching actual logic bugs and kind of more subtle edge case things. So not only does catching errors earlier improve reliability, it also leads to a much more effective test suite that kind of catches a complementary set of problems. And so I'm going to walk us through a number of examples showing what the new strictTemplates mode can do. And to make things easier, I've based them all on this common user interface. So a user is an object that has a name property. That name has first name and last name fields, both of which are strings. And because we're using one interface throughout, you can focus on the examples and not trying to figure out the different types involved. Another thing that I'm going to do is highlight all kinds of expressions within the examples that I show you. And this will show what is or isn't checked by the compiler. So anything highlighted in green is an expression for which we have what I would consider to be perfect type information. We know the most about it, and we can check it more or less completely. Anything highlighted in orange or amber means that while we are still checking it, parts of that expression we have incomplete information about. Maybe our compiler is inferring an any somewhere, and any's tend to be poisonous and kind of pollute the expressions that they're involved in and turn them into any's themselves. And of course, anything in red is something we're not checking at all. So first up, let's talk about how the new type checking mode differs from the previous two. Then we'll talk about how to go about turning it on in your applications without kind of getting overwhelmed by a stream of template errors. And finally, we'll talk about how this feature works under the hood. So to start off, I think it's useful to talk about the two modes of type checking available in Angular 8 and how they're different. So the first is the basic mode of checking that every application gets, even if it doesn't set any flags. And then there's the fullTemplateTypeCheck mode, which enables stricter checking that's been the default for some time in the CLI. So here's a pretty basic template that's going to show us nicely the main difference. We're going to display a user's first name, user.name.first. And if the ngIf is true, we'll also show their last name, user.name.last. And even in basic mode with no flag set, Angular version 8 will still check a few things about this template. It's going to verify that user.name.first is a valid expression, and that includes checking that user is actually a valid property of the component that we're writing. It'll also check that show last name is a valid property, and that ngIf exists and is something that we can bind to. But it's going to miss a few things. It's not going to check that the type of show last name is actually assignable to the input of ngIf. Thankfully, it will be because ngIf checks truthiness, so it'll accept anything. And it's going to ignore the contents of any embedded views. That's any ng-templates, any structural directives like ngIf or ngFor. Anything inside of those won't be checked at all. So it won't check the user.name.last expression. And so if we accidentally write user.lastName instead, the template type checker is not going to catch this. It's going to be a UI glitch at runtime, right? We'll probably show a blank last name. In full template type check mode, things get a little bit better. Angular is now going to correctly check the embedded views, the contents inside the ngIf, so it's going to validate that user.name.last is okay. But it's still not going to check that show last name is actually assignable to ngIf. And that's because the full in full template type check actually means it checks the entire template, both the top level template and any embedded views like ngIfs or ngFors. That's the main difference between these modes. So now let's talk about Ivy in strict templates and run through a few examples. I'm going to show you 4 of them where our type checking has improved significantly. So first, I want to talk about type checking of ngFor loops. Also, that check of binding assignability, so making sure the inputs of directives or components are actually compatible with the expressions that you bind to them. Inference of the $event type for output bindings. And last but not least, some fixes to strange behavior around the type checking of safe navigation. And since full template type check is actually the default in the CLI, that will be the basis for our comparison. The best type checking Angular could do in version 8 versus the best we can do in Ivy. Let's dive in. So the first example I want to show you is an ngFor loop that iterates over an array of users. And the ability to check ngFor has been one of those most requested features, and we can finally do it with Ivy. So what would happen in version 8? Well, even in full template type check mode, the compiler couldn't understand very much about an ngFor. Again, it'll validate that the directive exists, that we can bind to it, and that the array we're passing in is a valid expression. But it's not actually going to check, for example, that our user's expression is actually an iterable and therefore assignable to an ngFor. And with inside the ngFor body, the compiler actually has no way of knowing what type the loop variable is, so it treats it as any. And that means that our expressions, user.name.first, user.name.last, are actually all kind of fall apart and turn into any's. And so if there were typos in there, they would not be caught by the type checker. Here's kind of a similar form of that error. The compiler is able to verify that getLastName as a function is something that exists on our component and that we can call it. But because the loop variable is inferred as any, the compiler can't provide any safety around using it as an argument for getLastName. So under strict templates, this picture gets a lot greener. Thanks to our new template type inference, the compiler will actually be able to tell what type the loop variable is. So it can correctly type and check all of the expressions involving it. And this is the first time, as I mentioned in Angular, that we can do this. So one of the main differences between the previous type checking in strict templates is the check for assignability of inputs. So in this template, we're invoking a component called userComponent, and we're passing in an expression myUser. So previously, the type checker would verify that the expression was correct and that the input, user, exists, but it wouldn't actually check that the expression was compatible with the input. And so if you did something like pass in a string instead of the interface type that it expects, this would not be caught by the type checker, and this would probably crash at runtime. So one case where this can lead to some really subtle bugs or crashes is when you use the async pipe to wait on an observable. For example, if you're fetching data from HTTP. And until that observable actually emits data, an expression involving the async pipe will actually become null. And that means that if you bind an input to it, that input is actually going to get set to null until the observable emits some data. But because that wasn't being type checked, this could lead to UI crashes or glitches if the input wasn't actually expecting a null value. So with strict templates, we can actually tell you about this at build time. The compiler knows the async pipe is going to produce either a user or null, and it can check that both of those values would be compatible with the user input of our component. And if they're not, it can let you know with an error message. A similar thing happens for output bindings and the $event value. $event has previously been inferred as any. The compiler will verify that the event that we're binding to exists, but it won't be able to tell if what we're doing with $event actually makes sense given the output type of the event binding. So with strict templates, we can figure this out. The compiler will correctly infer the type of $event. It can check every part of the binding as a result. And the last example I want to show you is safe navigation. So in this case, let's assume we have a component here that has a user input that may or may not be set, so it might be undefined. And we'll declare a function in that component called formatName. And formatName is going to take the name in as a string and presumably format it for display. I'm just calling string.trim as an example. So naively, we may attempt to print out the name in our template using formatName. However, even in version 8, the compiler will correctly complain about this. It says the user property can be undefined, and therefore you can't just access the name property of it. And that's correct, right? But we can work around that. Angular has safe property navigation. Let's use it. That will allow us to do user question.name and not crash if user is undefined. Unfortunately, there's still problems with this, because even though it won't crash if user is undefined, the result of the overall expression, if user is undefined, is actually undefined still. It still has a value, right? And that's not valid to call formatName with. But the type checker here hasn't helped us. It doesn't know this, because it turns out some safe navigation operations in Angular were inferred as any. This is actually a bug in the old compiler. It wasn't trying to do that, but it worked out in certain cases that this happened. So under strict templates, as you might guess, we fix this. We actually catch this error. Now the compiler knows the overall expression is capable of being null and can tell us that's not legal to call formatName with. So the takeaway from all of these examples is that strict templates gives you much better type inference within your templates, and that translates to fewer runtime crashes or UI glitches when the assumptions that you're making about the data you're working with aren't quite correct or don't line up with what the type system says. How do you get there from here, though? If you have an application, I think someone asked this question on the stream yesterday. If you have an application that has like hundreds of components, it's not trivial just to turn on a new type checking flag and subject all of your templates to much more rigorous validation. There's probably going to be some failures, and it's annoying to have to fix all of them before you can turn the flag on. Unfortunately, we've designed strict templates for incremental adoption. So you can do that in 4 steps. And step 1 is the easiest. You turn on the flag and drink from the fire hose of failures, right? Then you look at each of the failures and try to figure out, why is it failing? Is it failing because we're now checking that an expression is assignable to an input and it's not? Is it failing because you're relying on safe navigation, inferring an any? And once you have that list of root causes, which is much shorter, hopefully, than the list of errors, you can selectively disable specific checks to hide them until you get them all fixed. And that means that you can turn on this feature incrementally, 1 check at a time, by disabling everything that's problematic until you've had time to go through and clean up your code. So there are a few reasons that you might have to do this. The most obvious one is if there are actual type bugs in your templates. But another thing that often comes up is if you're using libraries that weren't actually designed to be strict templates compatible. One case is if they weren't compiled with TypeScript-specific strictest settings, they might not specify null or undefined as valid values for an input, even if they're perfectly happy to accept that at runtime. So if the check that expressions are actually assignable to the inputs that you're binding them to is problematic, you can turn that off by setting the strict input types flag to false. As I said, you might do this if libraries that you're using don't have quite correct types for their inputs, or if you've been kind of loose about that in your own components. A special case of that is handling expressions which are potentially null or undefined. And that's because if a library is not compiled with TypeScript strict null checks, the DTS files that it produces actually don't include null or undefined as possible values. And so by turning off strict null input types, you can bypass that particular issue and still have the input assignability check working overall. Another problem tends to come up with attribute style bindings, as opposed to the square bracket property bindings. Attribute bindings are always strings, and that can cause issues if you're trying to bind them to inputs that might be expecting, for example, a Boolean value, like a disabled input. And you can set strict attribute types to false to work around that until you have time to kind of implement the changes in templates. If you happen to be relying on the previous inference of any types for safe property navigation, you can restore that behavior by setting strict safe navigation types. And the same goes for inference of the $event type for outputs and strict output event types. And in the case of DOM events, we have another flag, strictDomEventTypes, that affects the inference of $event for those. One case we've seen where people need to turn this off is if they're making extensive use of $event.target. You might assume, as I did when I first saw this example, that if we're subscribing to a change event of an input, $event.target will be an HTML input element. But DOM events can bubble, and so $event.target might not actually be the element that you subscribe to. It's in the type system, it's actually much more generic, and that can break patterns like this. There are a few other flags that I haven't specifically mentioned. They tend to come up a little more rarely in application code. You can read the full list along with some descriptions of why you might want to turn them off on the template type checking guide on Angular.io. So now that we've talked about strict templates and how to use it, I want to give you a small peek into how it works internally, how this feature was built, more because I feel like it's really cool. So let's go back to the ng-for example from earlier. I'm only going to talk about it superficially and not go into great detail about the type operations that are happening. I'm working on a blog post that's going to have a lot more kind of a technical approach to it. So here's our example template. We're iterating over a list of users, and we're printing out the first name of each one. And right away, we run into a problem because TypeScript doesn't actually understand HTML or Angular templates. So if we want it to check these expressions, we actually have to convert them into TypeScript code. This is code that you as a user will never see. This is code that does not get translated into JavaScript. It does not run in the browser. It does not run anywhere, actually. We feed it to TypeScript and allow TypeScript to check it for us and give us back any error messages. Then we take those errors and show them to you in the context of your original template. So that simple ng-for produces this complicated-looking piece of TypeScript code. And it is complicated in places, but what it's doing overall is fairly straightforward to understand. So let me walk you through it. The first thing it's doing is declaring a function called a type constructor for the ng-for directive. And that's because the ng-for directive is generic. Its type actually depends on the types of the inputs that you pass in. And so what this type constructor function does is, given a particular set of input bindings for ng-for, figure out what type the directive is going to be. The next thing this code is going to do is declare a function called a type check block. And this represents the entire template in TypeScript code. So it has one argument, which is a context variable that represents the application type. And the first thing this block does is call the type constructor for ng-for. You can see it's passing in the binding expression that we wrote for ng-for, which is context.users. TypeScript will let us know if that's not valid here. And then we get back this value t1, which actually has the correct type for the ng-for directive in this particular instance. It'll be an ng-for of user objects. Next, we ask the ng-for structural directive what type it's going to use for its template context at runtime. ng-for is free to create embedded views of any type that it wants, so we have to ask it, hey, what are you planning on doing? And it will tell us this t2 variable should actually be narrowed to a type called ng-for context that's generic over user objects. And inside this if block, we can now extract $implicit, which is the internal name in Angular for the let user variable. It's actually short for let user equals $implicit. And that's going to be the actual loop variable of type user. And that's called t3 here. Then all that we have to do is reflect the actual expression t3.name.first and let TypeScript tell us if there are any problems with that. Also, you might notice in the example here, there are comments with pairs of numbers kind of littered throughout the expression. These are our source maps. So if we get an error back from TypeScript, we can look at where TypeScript says the error is inside this code, find the nearest comment, and then use that to map the error back to the original template, so that when we show it to you, we can show it to you in the context of the binding expression that you wrote, and not the code that we generated to check it. So in summary, you should use strict templates. You should turn on strict mode in TypeScript as well, if at all possible. And don't be afraid to disable specific checks while you're migrating. It's much better to be partially strict for a while as you fix up errors in your templates than it is to never engage the flag because you just don't have time to go and fix all the errors in one sitting. Ivy has a very powerful template type inference and type checking engine. And we have a lot more ideas about new checks and new things we can add. For example, I don't think host bindings are checked at the moment. And with our strictness flag model, we can actually turn these on incrementally over time and roll them out to you without major inconvenience if you've already enabled the flag. Because if a new check is too breaky, we can actually release it as an opt-in mode. So that's all I have for you today. Thank you very much.